Chapter 1. Planning. Acoustic transducer installation is not an exact science. It requires a detailed planning process and a high level of experience. The key to a successful installation with good system performance is to create an optimum acoustic environment. Recommendations given by Kongsberg Maritime are based upon experience gained over more than 4 decades. The main challenge is to install the transducers away from aerated water and air bubbles. They are present under every ship. Aerated water and air bubbles will block the signal to and from the transducer. The shape of the hull is an important factor when planning an installation. The forward part of the hull, and especially the bow of the ship, will often determine the performance and the behavior of the echo sounder system. A bulbous bow can generate a sweep down of air bubbles. A straight and narrow bow reduces the sweep down of air bubbles. It is, from an acoustic point of view, the best design. A tunnel thruster will act as a pump every time the tunnel rises out of the water. It will grab air and push it down under the hull. It is recommended to close the thruster opening when not in use. A retractable azimuth thruster needs a large hole for deployment. This type of thruster should have a cover plate to close the hole when in the retracted position. The transducers should be installed in front of all thrusters when possible. There are often customer requirements which will influence the chosen installation method. Equipment which is already installed in or on the hull, or allowance for maximum additional draft, are some factors which can force the shipyard into choosing an installation method which is less than optimal. There are, in general, 4 different installation methods. The gondola installation. A gondola is like a pod hanging down from under the ship's keel. The transducers are installed inside this unit. There is a gap between the gondola and the ship's hull. Aerated water will pass through this gap and thus not be pushed under the transducer face. This allows for optimal acoustic performance within a wider weather window and is generally our preferred installation method. The blister installation. A blister is a mounting construction fully welded to the hull of the ship. It contains casings which form the main part of the unit, housing the transducer frames and modules. The aim of this design is to direct the aerated water to the sides of the installation, thus ensuring a good acoustic environment for the transducers. Blisters of different sizes and shapes have been used from the early days of echo sounder installations. The flush-mounted installation. With a flush installation method, the transducers are installed inside the ship's hull. The transducer faces are then leveled with the surface of the hull. This method exposes the transducers to passing air bubbles, which will affect the system performance. On ships with sharp bows, deep drafts, and ideal acoustic conditions, the method might be acceptable. If selected, great care must be taken during the planning process to ensure best possible transducer location. It should be mentioned that for an icebreaker there are no other alternatives than a flush installation, where the transducers are protected behind ice windows. The benefit of a flush-mounted installation is that nothing protrudes from the keel, adding additional draft. The drop keel installation. Transducer installations in drop keels are becoming increasingly common. This method allows the transducers to be deployed 2 to 3 meters beneath the hull to areas away from water disturbances. The installation is also better adapted to harsher weather conditions than other methods and gives a wider weather window. A limitation of this method is the size of the transducers that can be installed. A drop keel, which is retracted, gives ideal protection to the transducers. Drop keels first became the preferred installation method for research ships. These ships have high demands in terms of transducer operational environments and acoustic noise. Chapter 2. Design. A number of factors may influence the actual design of the mounting construction. Such factors are the relationship between the hydrodynamic properties of the hull, the selected location of the mounting construction, and also its design. Installation Manual. A detailed installation manual is available for all KM multibeam systems. It is recommended that the manual is used both during the design phase and under actual installation of the transducers. The Kongsberg Maritime project team will be able to offer valuable advice based on extensive knowledge and experience from transducer installations. A Kongsberg Maritime project manager is, of course, always available to discuss any issues related to the project. The installation method selected and all the work associated with design and installation are always the customer's responsibility. In many cases, the customer will have other equipment which needs to be installed on the ship's hull. Depending on the physical and operating characteristics of the equipment, care must be taken to find placements that do not reduce system performance. Mounting frames. The KM multi-beam transducers are always mounted in the transducer frames supplied as part of a standard delivery. The high-quality steel frames serve as a rigid and stable container for the transducers. The frames ensure that the transducers are perfectly aligned and that they keep the same position throughout their lifetime. A key requirement for transducer installation is that the frame is mounted flat to an accurately aligned foundation. The specifications for this alignment accuracy are given in the installation manual. Bolting method. The transducer frame must be bolted onto the specially prepared flat bars inside the casing or mounting construction, using the torque specified in the installation manual. It is during this process that the alignment of the transducer frame is done and that the frame is mounted completely flat within an accepted deviation. Plastic and steel shims are used at the bolting points along the frame to adjust it horizontally. The thickness of the shims used will vary depending on the results from the alignment measurement. Several rounds of adjusting and shimming may be necessary to achieve the required accuracy. Distance from transducers to edge of construction. Kongsberg Maritime recommend having approximately 30 centimeters between the receive transducer and the curving edge of the mounting construction. This will minimize the acoustic noise generated by turbulence along the edge of the blister or gondola. Galvanic protection. The steel frames used for the transducer mounting are made of high-quality steel. In salt water, a galvanic potential will be generated between the frames and the surrounding metal. This can give rise to corrosion. Protective paint and zinc anodes are used to help prevent corrosion. The location of each anode should be decided during the design phase. The zinc anodes should be bolted, not welded, for easy replacement. They must be placed in a position where they give maximum protection to the mounting bars. Surface requirements. Objects protruding from the hull generate turbulence and flow noise. Also, holes and pipe outlets are noise sources. They may act as resonant cavities, amplifying the flow noise at certain frequencies. Thus, the transducer array should not be located in the vicinity of such objects, and especially not close behind them. Welding seams. Welding seams should be smooth in order to minimize the risk of turbulence and flow noise. This is especially important on the surfaces forward of the transducers. Kongsberg Maritime engineers will inspect the installation area and list potential problems. Air outlets. It is important that all cavities with transducers are filled with water. For this reason, air outlets are needed to release the trapped air. Paint schemes. Both the inside and outside of the mounting construction should be painted according to the paint scheme of the vessel. Marine growth on the transducers will have a detrimental effect on system performance. To reduce this, the transducer face should be painted using an appropriate anti-fouling paint. Cover plates. Cover plates are bolted around the transducer frames. These will close the gaps which are present and which are necessary for installation and maintenance. Cover plates are specially designed and can be made of steel or POM. POM plates are easy to fit and handle and may be an excellent alternative to steel. Steel conduits. The transducer cables are led through the vessel's hull to a point above water level inside steel conduits. Each conduit must be closed at the top with a watertight barrier. Roxtec and Bratberg are recommended manufacturers. Installation of the steel conduits must be approved by the vessel's classification authority and hence carefully planned. Straight conduits are always recommended for easy pulling of the transducer cables. Use of two bends of up to 30 degrees each is acceptable. A bigger bend may impede the cable pulling and should be avoided. The number of required steel conduits depends on the echo sounder model and system configuration and may vary. Close to the top of each conduit, a valve is fitted to allow air ventilation. Cable routing considerations. Kongsberg Maritime's echo sounders are supplied with a standard cable length, depending on the transducer type. Excess cable can be stowed in available space in the mounting construction. Cable routing and stowing should be considered carefully during the design phase of the installation. Installation space. KM recommends having a clearance of at least 1 meter between the dock floor and the blister or gondola surface. This is especially important for the bigger systems, where up to 112 transducers need to be lifted and inserted into position. If the space under the hull permits, KM recommends using a lifting trolley to ease handling and installation of transducer modules. Proper working conditions should be given high priority to increase efficiency and worker safety. Chapter 3. Installation. Mounting considerations. Before the on-site arrival of the Kongsberg Maritime engineers, a number of tasks should be completed by the installation shipyard. All mechanical installation work is to be finished, all welding, blasting and painting completed. The steel conduits for the transducer cables are to be installed and welded in place. Watertight barriers are normally installed on top of these conduits. The conduits must be approved by the Ship's Classification Society and are outside Kongsberg Maritime responsibility. The required number of sacrificial zinc anodes inside the mounting construction are to be bolted in place before any transducer installation work is started. The installation area must be clean and dry. Aside from the immediate effect of easing the work for a number of people, a clean working environment will reduce the chances for accidents involving both people and equipment. All of these points will be verified through a visual inspection upon the arrival of the Kongsberg Maritime engineers. Manpower and tools. The main purpose for the Kongsberg Maritime Service Engineer is to coordinate and supervise the yard activities during installation. The yard should provide sufficient numbers of people for the installation work. This includes dock workers to do the frame and transducer installation and electricians for all cable work. The mounting frame installation. The installation of the transducer mounting frames is done by the shipyard under Kongsberg Maritime supervision. After the frames are bolted in place with the correct torque as specified in the installation manual, the flatness of the frame will be verified. This is done by a dedicated and well-qualified land survey team. Deviations from the desired flatness of the mounting foundation can be compensated for by using plastic and steel shims. These shims are inserted at the bolting points along the transducer frame to achieve the required accuracy. This is a critical and important part of the installation. Several rounds of measurements and shimming may be necessary to achieve overall accuracy. When the frame is within specification, each bolt is loosened in turn, injected with Loctite, normally 242, and tightened to the required torque. When this is completed, the installation team is ready for transducer installation. Before installation of the transducer modules in the frames, it's recommended to arrange the modules with increasing serial numbers. The transducer modules are sensitive to shock and must be handled with care. Remove the clamping bars from the frames. Install the modules with increasing serial numbers, starting from one end of the frame. Fill in the table, location of modules in the installation manual. It is vital to know the location of each module in the transducer array. Secure the transducer modules with the clamping bars. Secure the bolts using Loctite and fasten them using the recommended torque. Uncoil the transducer cables, guide them along the mounting frame, and pull them through the conduit and the pre-installed cable glands on the top of the conduit. Verify that all cables are properly secured and not exposed to wear and tear. Installation and sealing of all cable glands must be performed by qualified personnel. Install the protective cover plates using Loctite on the bolts. As a final precaution, all gaps in the area around the transducers exceeding 3 mm should be filled in using an appropriate material. The ship's painting scheme should apply to all areas except the transducer faces. Remove the protective tape from the transducer face. Wash all transducers using a standard liquid soap. Rinse properly and let dry. Rub the transducer face gently using minimum grade 180 sandpaper before applying anti-fouling paint. Positioning system and motion sensor. A vessel's roll, pitch and heave values are vital inputs to any multi-beam echo sounder. The same is true for accurate global positioning, together with the ship's heading. These parameters are normally supplied from a combined attitude and GPS positioning system. This system also provides accurate time, which can be made available for the entire ship. The positioning part of this integrated system